Okay, so we're going to start with making something called the mode framework. So again, it's going to be a way to subdivide our draw function into sort of separate modes. So you don't have to program your start screen in together with the same code that is your game, which is the same code as your game over. It's just going to make our organization so much better. I guarantee that in this classroom, half of you, if not more, probably more, at some point screwed up a brace somewhere, right? Like if some brace went wrong and you put a void in another void by accident, or you ended your whole function early and some code ended up outside of a function, and it was just annoying. So this is going to help us avoid those problems too. So I'm going to just put out our usual void setup. Brace. Always, if you open a brace, close it right away. It's just, you're going to forget. As a human being, we're just going to forget these things at some point. Void draw, brace. You know what? It doesn't really matter what screen size we're doing. And if you're going to do the Android project, by the way, this will be something to consider. I'll just put 600 by 600. Probably should tell you what game we're making first. Actually, I'm not going to. It doesn't matter. I actually like that we don't know what game we're making yet, because the code we're doing right now is for all games. Every game or state-based program that we ever create. And guess what? We're going to control the entire game state or the game mode, what mode we're in, with a single int variable. And this is what is going to make this worthwhile for everybody. Int mode, I'm going to call it. Boldly, I will call it mode. And we're going to just make some numbers that will represent what mode we're in. We'll start pretty simple. We'll just, our basic game we're going to create, whatever little boring game that's going to be, it's going to have 3 different modes. It's going to have sort of the start screen mode, there'll be the game itself, and there'll be a game over screen. 3 modes, just to keep everything pretty simple. So we're going to have, I'm just going to make a comment to remind myself. One will represent start screen, or intro screen maybe is a better way of doing that. 2 will represent our game, this game itself, and 3 will represent our game over screen. So it's almost like we're going to have 3 separate projects. There'll be an animation or at least a picture for our intro screen, an animation or picture or something for our game over, and there'll be an actual part for the game. But we're going to subdivide into 3 separate problems to solve. Xavier, question? Oh, did I not log in for you? Oh, that's so bad. I feel so bad. Sorry. That's terrible, Alexander. So sorry. You're probably feeling pretty bad. Good thing I'm recording a video right now. Then my shame will be uploaded onto YouTube forever after. Yeah, so worry about that. Okay, back to it. And when you go to watch this video, Alexander, you'll hear me apologizing to you over and over. You just rewind it. I'm sorry, Alexander. Just scrub it back over and over and over again. Okay, so mode. This is our variable that's going to control what mode we're in. And it's going to be so powerful that when we want to end the game, we'll just say mode equals 3. And that'll just go to game over. When we want to restart the game, we'll say mode equals 1. And the start screen will just come up. And when we want to start the game, we'll just say mode equals 2. And we'll just make the game start happening. And just everything will be controlled from this one variable. So good. I'm going to start mode at 1 would probably be the logical place to start it, right? I'm guessing that's probably a good place to start it in. Actually, later on, you'll see that we can manipulate this variable just to test our game. If you want to just test the game over screen, you can start it at 3, so we start in the game over screen. So you can kind of program that and make that work. Okay, so next is going to be the draw function. And this is really, the variable is nothing special. It's just an int like any other int. So what makes it special is how we use it. Just like everything, right? The slider, that x variable for the slider, it's just an int, nothing special. But because it's set to mouse x as we drag the slider, that's what makes it interesting. And the fact that we map it to some value to get it in the right range, it's what we do with the variable that gives us its power. So we're going to have an if statement where we're going to sort of break this draw function into 3 separate parts. So I'm going to say, hey, if mode equals 1. Notice that there's 2 equal signs. That wasn't a typo. I don't think we've actually experienced this yet in the course where we're just checking to see if an integer is exactly some value. Usually we've done greater than, less than, but you could check to see if it is exactly equal to a certain number. And we use two equal signs. So this will be something we will get wrong. I get this wrong from time to time because that's not intuitive. This doesn't really look correct even when you know it's right. And you might wonder, why do you have to use two equal signs? Like, why can't I do this? Anybody know? Or anyone have a guess? Yeah, Bora. Oh, you know. It seems good, right? But how do you distinguish this from this? Right? Like here I'm assigning the value of 1. I'm making mode 1. But here I'm asking the question, is mode 1? Question mark? You know, like this would make mode 1, but I don't want to make it 1. I want to ask, is it 1? And if it is, let's do some stuff that's separate from other things. So there's me right now asking, is mode equal to 1? Right? And that's just by default, that's our intro screen code. I'm choosing 1. You could choose any numbers, by the way. You could choose 666 and 42 and like whatever numbers you want to represent these things. And later on, we're actually going to abstract it completely from the numbers. So we'll just use words later on, but not today. We'll do that later. So anyways, that's if mode equals 1, then we'll do some code in here. I'll leave this blank for now. You could then do another if mode equals 2. But I'm going to show you something slightly different. Instead of saying if, I'm going to say else if. Mode equals 2, then I'll do the next thing. And then another else if, and I'll tell you about this in a second. I'll just get the code down on the screen. And then a final else. And I'll tell you what the difference is between just a bunch of ifs and if, else, if. So I'll let you guys write down this structure. This is the mode framework, by the way. Let me just put this out here just so I have like, you get the words up here on the screen. Mode framework. All this stuff is the mode framework that is going to enable us to kind of switch between the different modes of the program. I'll just listen for the keyboard clackety clacks. And as they get quieter and quieter, then I'll assume that people are succeeding. Again, apologies to the row whose backs have to be to us. I'm sure you guys are. How's that core? Like you're probably like I don't know, like 30% increase in core strength just from like all the swiveling and stuff. We should just get you guys swivel chairs. That's only fair, right? You guys have swivel chairs at least. I'll see what I can do. Okay, the clackety clacks are coming to an end. So I'm assuming people have typed this down. So I just wanted to highlight like what's the difference between what I've written down and just having a bunch of ifs here. So the if statements are things that just happen one after another. If you have just an if, then it asks this question, and it either does that code or not. And then it'll ask this question, and it'll either do that code or not. And whether it does that code or not, it will go to the next if and then ask that question. And then this else doesn't really make much sense in this context. So it would ask 3 questions in this structure. Always it would ask if mode is 1, and then it would ask if mode is 2, and then it would ask if mode is 3. Whether or not they succeed or fail, those 3 questions will be asked.
If we write else, like,
yeah.
just ask the mode 1, and if it's true or not, we'll continue.
You got it. So in case you didn't hear what Bora just said, the idea with if, else, if is this becomes a continuous chain.
Yeah.
And if you ever break the chain, then it stops asking questions. So in other words, if mode actually equals 1, it will do this code here, whatever code is in here. It'll run that code, and it won't do any of the rest of it. It stops. And that way, say for example, you had some like messed up code like this. Mode equals 2 in here. It won't all of a sudden then like immediately start doing whatever's in the next thing. Like only one of these 4 possibilities will happen in any given frame of the draw function using if, else, if. So if this fails, it'll check the next if. If that fails, it'll check the next if. And then if this one fails as well, it'll finally go to this catch-all else statement. Notice there's no if in the final else. This is like the catch-all. Everything has failed. Nothing is going right. All the questions were false. So this is like, what do you do if none of those are true? And in this particular project, that doesn't make sense, right? Mode can only be one of these three things by definition of our game. So this is an example of a weird error that has happened. Maybe your friend typed in some like code. Check out this code. Mode equals 69. Ha ha ha! Isn't that funny? And then if you didn't see that, and then your code ran, nothing would happen. Like the draw function would just be blank. You'd be like, what's happening? So just to avoid that really annoying error of like what happens if your mode isn't one of the predefined values, we'll have this else that will catch that problem. And I'll just use print line, but you guys could use anything like a big red rectangle you could draw here. That actually might be the best thing because it would be visual. Maybe I'll just do background 25500. Big red screen will appear, and that indicates that mode isn't 1, 2, or 3. And that's a bad situation because that it has to be one of those modes according to our game design. So big red background will tell us that someone has typed in something into our code, or maybe you've accidentally typed in something into your code to switch mode out of the right values. All right, so now what are we going to write here, and here, and here, and so on? So remember our definitions. 1 is for intro screen, 2 is for game, 3 is for game over screen. So you could go ahead and start programming this in. And you could type in your intro screen code in here, text, game, awesome game, like whatever your game's name is. Put it at whatever coordinates and like fill and all this kind of stuff. And you can even make it an animation, and you can put all this code in here. But you know what happens when you, like, for example, our animation project you guys handed in a couple of weeks ago. Like, that's a lot of code. That's a lot of code. So this whole mode equals 1 could be its own project unto itself, and we won't, for this project, make it so hard. Don't worry. We'll keep it light. But we should probably get used to the idea of having separate spaces for these different modes of our program. And so what we're going to do, instead of just start typing like rect, blah, 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 and fill and all this kind of stuff right here, we're going to make a function that will represent all of the code that does the intro screen. I'm going to call it intro screen. And when you do this, it'll highlight it as red. I don't have the inline editing going on, or inline error checking. I'll turn it on just to make sure. So mine looks like yours. It should highlight, red. It says, the function intro screen does not exist. Well, yeah, I know. I didn't write it yet. And this is a very powerful way to program, just so you know. Don't start your program by typing in the rects and the fills of your intro screen and then move on to the rects and the fills and the math of the game. Plan everything out in advance and organize everything in advance, and you will save yourself so much time. If you were to think about any previous project and think about how much time did you spend writing code and how much time did you spend figuring out what was wrong with the code that you wrote. Think about that ratio. What is that? Probably like 50-50 on a good day, right? I know for me, it's probably 50-50. You spend so much more time, especially when you get into complex stuff, looking for your errors. So by thinking about things and planning them out, subdividing your program, you are just going to avoid a lot of errors that will otherwise have been a pain. So I'm going to have intro screen is going to be one of my functions. I'll have whatever you want to call it. I'll call it the game. These names aren't important. And then I'll have game over screen. I should probably be modeling Camel Case. This isn't how anybody writes function names. I don't want to confuse anybody. So, but I do want to actually mention Camel Case. If you work in Google or for NASA or for Facebook, there's specific conventions for the way you name functions. Even though processing in Java doesn't care, Mark Zuckerberg cares, and whoever is the director of NASA cares. There's this thing called Camel Case, where when you give a name for a function, you always capitalize all of the sort of sub-words inside of the function after the first one. So for example, game over screen would be capital O for over and capital S for screen. This is just a convention that people have come up with, and it supposedly helps with the readability of your function names. So I'm going to do that just to model it. Does it matter? I mean, ultimately no, but if you have any ambition at all of going into the software industry or writing code that might be, viewed by other people, then this adds that veneer of professionalism to your code and is generally more readable.
Some languages like don't want you to write your code in like capital letters. They just want things like.
I suppose I can't think of a particular language that would care too much. Like maybe Fortran is like the last one I can think of that would care. But like if you're looking at C, C++, Java, like those are all languages that will use Camel Case. So like the big languages, Python. We could go on. But anyways, I've talked too much about it. So anyways, red lines. We got to solve these red lines. So we could go make void intro screen, void the game, and so on. But guess what we're going to do? We're going to do another organizational strategy here that I think you guys will like. We're going to make new tabs for the different modes as well. So all of our code for, say, the intro screen will be in a separate tab. It'll just save us from all the endless scrolling. My goodness. Sketchpad. I would come over to people's seats and they'd be like, Mr. Pelletier, I have a problem with my slider, for example, or whatever it was. And I'd be like, oh, show me that piece of code. And then we would spend the next 2 minutes scrolling down. Oh, wait, no, up. No, down. Wait for it. Oh, no, there it is. Yeah, it's just like so much scrolling. Let's give our mice a break, or our trackpads, or whatever you're using. I'm gonna make a new tab. Oh man, you're never gonna go back. I forgot how to zoom on a Mac. What is it? Command Option plus. Hey, I figured it out. So, do you see this tab here? Right beside it is an arrow, a little down arrow. If you click on the down arrow, you get a menu, including new tab. And this is great. If you make a new tab, it'll ask you for the tab's name. And it actually does create multiple files in your project after this, which will be kind of annoying, but not a big deal. It's not going to be really a make or break problem. It's so much better to have the organizational system. So I'm going to make one for the intro screen. I'll call it probably intro screen. It doesn't have to necessarily be the function name. It's just going to be kind of the general kind of code that's going to be in this tab. So I'll just call it intro screen because the modes will pretty much map to the tabs today. I'm going to make another one called the game. And I'll make another one called game over. And I'll probably have a final one that's for doing things like mouse clicks and that kind of stuff. So I'll make a final one. I'll probably call it mouse, interactions or something. So by the end of it, I'll show you my tab structure. You'll probably want to name the first tab. So you have your first tab, and then they just order them alphabetically. So even though the game over isn't the first thing that you're going to probably tackle, it's just G comes before I, comes before M, comes before T. So you just I don't know, whatever. That's just the way it is. So we got all these tabs. So now, when I go to write intro screen, void intro screen, I'm going to put it in the intro screen tab. I'll put void intro screen over here. And then where I'm going to put the game, that function, I'm going to put it in the game tab and put void the game. Again, I could put more than just that function in there, but right now the game is so simple that we could probably just, the mode and the tab and the function are all sort of seemingly similar things. Then we got the game over screen. Sure, I'll stick that in game over tab. Void game over screen. So we've spent about half an hour just organizing our code right at the beginning. And this is how pretty much all software is written. The guys that wrote, I can't think of a good example, Call of Duty. Whoever wrote Call of Duty, they didn't just start like typing in, like 3D graphics code. They actually sat down and planned out every function, every variable, how all those will interact before they ever wrote a piece of code at all. Because when things get complex, you can't just start in the middle, start organizing things after you've already written down code. So here's our structure. We have our main tab. It's got void setup and void draw. By the way, this top of the main tab is still where we're going to declare our variables. It's still the place to do it, so all our variable declarations are all in here. And then we have our mode framework. So we're deciding which part of the game we're in. And then each of these different parts is going to live in a different tab. So the intro screen code will all be here. The game code will all be in here. Game over will all be here. And the mouse interactions, oh yeah, in mouse interactions, probably void mouse release. This would be a good place for it to live, over here. And we now have really well-organized code, and hopefully this will help reduce those, it says I'm mixing active and static mode, or it says I'm missing a brace, or all those little annoying problems that end up happening as you're programming. So that's what we call the mode framework. You might want to save this right now. Just save it completely separate, and then when we start a new game project, you can just start with this sort of mode framework already built in. You don't have to, but guess what? We're going to use this in like all of term 2 and much of term 3 as well, as sort of the way we define stuff. And we'll have more modes eventually. So I guess before we finish, I just want to make sure, is it clear what a mode is? Or do people feel confident that they understand what the different, the concept of having a game having different modes in it? Is that a clear idea? Yeah? And so, again, we're just using an integer to keep track of which mode we're in. And because our draw function's subdivided into, I guess, technically four, but really 3 separate areas, we can sort of use that one variable to decide, what are we drawing? Are we drawing the game? Are we drawing the intro screen? Are we drawing the game over screen? Whatever it is we're doing. Okay, so I'm going to save that. And you guys probably should save it too if you haven't already. I'm just going to call it mode framework. Okay, so you're probably wondering, what game are we writing? This is where the video, I think, will end, because what we're going to do is on the whiteboard, and I don't have a great way of doing this on the screen. We have to do a little thought experiment first. But I will record what we do after this. So I'll just go over here and stop recording. Bye.